Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today, let's talk about another example, how to apply Newton's laws to solve problems. This question is from past AP exam from 2005, number 1. A ball of mass m thrown vertically upward with the initial velocity of v0. It experiences a force of air resistance given by the equation F equals negative kV. That means the air resistance is always opposite in direction to the velocity, where k is a positive constant. The positive direction for all vector quantities is upward. Express all algebraic answers in terms of m, k, v0, and fundamental constants. A. Does the magnitude acceleration of the ball increase, decrease, or remains the same as the ball moves upward? And you have to justify your answer. So in order to figure out how the acceleration changes, we need to start with free body diagram. So here is as the ball moves upward, v is positive, but kV air resistance and mg is negative because upward is positive, downward is negative. From Newton's second law, we know net force equals ma. Net force is negative kV plus mg equals ma. So from here we can solve for a. A is just negative kV plus mg over m. And what happens as the ball goes up? What happens to v? So as the ball moves upward, its velocity decreases, becomes to 0. Therefore, as it moves upward, acceleration has to decrease. So the answer is decrease. And this is how you justify your answer. Part B. Write but do not solve a differential equation for the instantaneous speed v of the ball in terms of t as the ball moves upward. Differential equation means to write a derivative symbol in your equation. Here is the equation. So for the instantaneous velocity, so we have to leave the v here. And what is a? A is just dv over dt. So you simply substitute a with dv over dt. That is your differential equation. Part C. Determine the terminal velocity of the ball as it moves downward. So in order to do that, we need our free body diagram. So as it moves downward, we know air resistance is upward and the gravity is downward. So at terminal velocity, we know by definition, sum of the force has to be equal to 0. That means kVt, this is terminal velocity minus mg equals to 0. So from here, you solve for vt. Vt equals mg over k. That is the terminal speed. Part D. Does it take longer for the ball to rise to its maximum height or to fall from its maximum height back to the height from which it was thrown? You need to justify your answer. So again, let's go back to our free body diagram. So already we figure out acceleration while it's moving up is the sum of the force divided by m. So it's negative. This negative indicates direction. It's negative kV plus mg divided by m. While it moves down, since gravity and air resistance are in the opposite direction, and up is positive, so a equals kV minus mg divided by m. As you can see, the magnitude for a is bigger while it moves upward. The acceleration has a smaller magnitude while moving downward compared to moving upward, because this is the difference between the two forces. While it's moving downward, moving upward, the two forces are in the same direction. Since acceleration is smaller while moving downward, so it's going to take longer for the ball to fall. Last question. On the axis below, sketch a graph velocity versus time for the upward and downward parts of the ball's flight, where Tf is the time at which the ball returns to the height from which it was thrown. So in order to graph this VT graph, or sketch this VT graph, we need to know a few things. Let's just review. We know the ball is going to take shorter time to rise than to fall. That means if over here is coming back, at the very top to rise, the time has to be before the middle line. It takes shorter time to rise than to fall. Another thing we need to know is the acceleration of the ball actually decreases because acceleration depends on v. As v decreases, acceleration decreases. Next one, when the ball reaches terminal velocity, before it returns to the height at which it was thrown. So you'll have terminal velocity. This terminal velocity will be less than your v naught. So you have v naught and your terminal velocity. And your graph should have decreasing slope. And the middle point should be less than half of the total point. So that should be your graph. Okay, that's it. I hope it helps. And thanks for watching.